In a change to some programme listings and as part of lockdown learning now, Science Week continues on Bitesize Daily with a rocket launch.
T-minus 30 seconds until liftoff.
Space helmet. Check. Moon boots. Check. Favourite move in chess. Check. Hello, I'm Ben Kajee, and our latest Bite-Sized Daily is only seconds away. It's Science Week, so we're taking you one giant leap into space.
T-minus 20 seconds until liftoff.
Not long now, we've got a great show lined up, and you're going to be brighter than the sun by the end of it, with the help of some out-of-this-world experts and big star celebs too.
T-minus 10 seconds until liftoff.
Here we go then. 3, 2, 1, ignition. Whoa! Coming up, we lift off with how rockets are propelled into space. Our awesome scientist of the day is real-life astronaut Major Tim Peake. There's more of our big read, The Extraordinary Life of Greta Thunberg, read by the author Devika Jina. And our friends at the Science Museum in London have an explosive experiment for us.
Hi, Ben. That's right, we're getting ready to launch our very own Science Museum rocket. See you for the launch soon.
It's Science Week, and today we're looking at space and how we get there. At the end of May, the world watched this historical moment as 2 NASA astronauts were sent to space on a rocket built by a private company, SpaceX, a breathtaking sight. But have you ever wondered how rockets are able to propel themselves up into space? It's all to do with force, and we've got an experiment to show you how. But first, to infographic and beyond.
Newton's third law. Newton's third law of motion states whenever 2 objects interact, they exert equal and opposite forces on each other. Are you sitting comfortably? You're exerting a downward force on the chair, but the chair is pushing back up to you with an equal force to keep you there. When we walk, we push against the ground, and the ground pushes back with equal force. Rocket and jet engines are propelled forwards by the forces produced when the fuel combusts. The gases are forced backwards out of the exhaust, which push the rocket forwards. Newton's laws work in space too. Rockets can be maneuvered with jets that can push the rocket in different directions.
It's absolutely amazing to think that humans have made it to space in rockets. And to help us get our heads around the science that makes it possible, we're joined by a very special guest from the Science and Industry Museum in Manchester. It's our explainer, it's Maxwell.
Hi, Ben. It's great to be here.
It's great to have you here. Now, this is really where the show will take off, as you've got a rocket experiment for us. Where's the launch pad?
It's this table right here. Today, we're going to be doing an activity called Rocket Mice and challenge the old saying, what goes up must come down. You won't get this rocket into space, but some rockets do go fast enough to prove the old saying wrong. You will need a Rocket Mouse template, a plastic bottle, some scissors, some sticky tape, and if you want, maybe some decorations. First thing you need to do is cut out your template and roll it into a cone.
Yep.
Then secure it with some sticky tape. And there you have it, your rocket. You can decorate it however you like, but I've chosen a mouse.
Are you ready to do one giant squeak for mankind?
Now, are you ready for the exciting bit? The launch. Place your rocket mouse on top of the bottle and with your arms extended, give the bottle a good whack. Are you ready?
I'm definitely ready for this, yeah.
3, 2, 1, launch.
Hey, amazing, look at that. It was so good, came right off. So how did it work?
When you squeeze the bottle, this increases the air pressure inside and that exerts a pushing force on the rocket, which sends it flying. How do you think this rocket is different to a real rocket?
Well, it can fly across the studio, but it definitely can't fly into space.
Although my rocket quickly came back down to Earth, real rockets burn a lot of fuel to give them enough energy to escape the Earth's gravity. This is called reaching escape velocity.
And now at home, you could try different rocket mouse designs to see how they work.
Yes, you could make your rocket spin or even use different sized bottles. or use your curiosity and imagination to make your rocket mouse go as high as possible. I'll try this one I decorated before.
OK, the blue one. Ready?
3, 2, 1.
Hey, that was a good one. That mouse flew so well, it should be decorated with a medal. Maxwell, thank you so much. Later on, we'll be bringing you an incredible rocket experiment that's going to go off with a bang. You definitely don't want to miss that. And there's loads of amazing science videos, guides and quizzes over on the BBC Bitesize website. It's Science Week here at Bitesize Daily, and in the big read, we've been hearing extracts from Devika Jina's book, The Extraordinary Life of Greta Thunberg. Yesterday, we learnt that in August 2018, Greta had to go against her parents' wishes to miss school and sit in front of the Swedish Parliament building to take a stand against the climate crisis. Her friends supported her, but they didn't want to miss their lessons, so she went on strike alone. Little did Greta know, she was about to start a huge global movement and inspire millions of others. And continuing the story for us today is the book's author, Devika Jina.
Greta's solo strike continued every day, just as she had promised. And on 7th of September 2018, she went even further. Greta announced that she would continue the strike every Friday until the Swedish government committed to reducing their carbon emissions, as set out in the Paris Agreement of 2015. We live in an age where social media connects us with each other and allows us to talk about important issues like climate change. And Greta's story shows just how powerful this can be. The image of a 15-year-old girl, hair in plaits, cross-legged outside the seat of the Swedish Parliament, spread far and wide. Soon, Greta wasn't alone anymore. Millions more in hundreds of countries across the globe joined her. And so, the Fridays for Future movement was born. Fridays for Future was started by Greta, and soon after, there were other young climate activists who began setting up marches in their hometowns. On 30th of November 2018, around 15,000 schoolchildren in 30 cities up and down Australia followed Greta's lead and took to the streets, and the revolution was spreading. More and more young people were making signs and marching in the hope that finally their leaders would pay attention. A month later, in early December 2018, preparations were almost finished for the United Nations Climate Change Conference in Katowice, Poland. Knowing that political leaders were getting ready to discuss the burning issue, millions more young people made preparations of their own. In the lead up to the conference, and during it, strikes were organised in 270 cities across the globe, from Belgium to Japan. Meanwhile, Greta had been invited to speak at the conference. She thought it was funny that the people she was calling on to act had invited her to speak about a problem that they weren't doing enough to resolve. I think it is insane that people are gathered here to talk about the climate, and they arrive here in private jets.
What an inspiring story. And here to discuss it with me is science sensation, Dr. Tim Gregory.
Thanks for having me, Ben. So Greta's story is a really important example that shows how science really impacts modern society, but also how modern society impacts science.
Absolutely, and that's a really good point, and specifically social media in this case. It's had such a huge role to play in Greta's story.
It really, really did. Greta's perseverance in striking every Friday really sparked a movement. You know, this image of a 15-year-old girl, hair in plaits, cross-legged outside the Parliament, went viral on the internet, and within just 3 months, Greta had convinced millions of others to do the same around the globe.
And she was using a hashtag too, wasn't she? Hashtag Fridays for Future.
Yes, she was, and as the author says, the revolution was spreading. The protesters shared their support on social media, they posted pictures and videos. In fact, the impact of social media was so powerful that 15,000 school kids started striking in Australia, which is right on the other side of the world to where Greta started.
Amazing, and she didn't stop there, did she?
No, she didn't. Greta was given the opportunity to speak at the UN Climate Change Conference, And she said that she thought it was insane how the attendees had travelled to the conference on climate change by private jet. She said they were all hypocrites.
Ooh, burn. Greta's like...
Yeah, absolutely. And this was one of her strategies, to point the finger at people in high places, those in power. She pointed it straight at them. And again, this helped spread a message, and people shared it widely on social media. It went viral. And look, now we're still talking about it a year on.
Yeah, we sure are, and we'll be hearing more of the extraordinary life of Greta Thunberg tomorrow. But if you can't wait that long, then why not look at your local library online for ebook and audiobook copies? Right, don't go anywhere, Dr. Tim, and you don't go anywhere either, because there's more science coming up next. We're only moments away from our big experiment, but before we see it, what scientific nuggets have you got for us, Dr. Tim?
Well then, earlier we saw how forces work in pairs to move objects, and in the case of the rocket mice, up into the air.
Yeah, though sadly not as far as space.
Not quite into space. For rockets to get high enough speeds to escape Earth's gravity completely, they're powered by gases, and it's the reaction of these gases that propels the rocket upwards.
Well, we're in for a treat because Alexandra and Sam from the Science Museum in London are going to show us how that's possible right now. And remember, do not try this at home or anywhere else for that matter.
Today, we're going to be launching a rocket. Now, I have my rocket here, but in order to understand the journey that our rocket's going to take, we need the help of a very famous scientist called Sir Isaac Newton. Now, Newton was really interested in the way things move, so much so that he came up with the 3 laws of motion. And it's his 3rd law of motion that we're going to take a closer look at now. Newton's 3rd law of motion states, for every action, there is an equal and opposite reaction. But what does that mean? Well, he states that if a force pushes something in one direction, there is an equal force pushing back in the opposite direction at the exact same time. And we're going to use my rocket here to demonstrate it. Now, I'm going to fill it with a gas called hydrogen. Now, hydrogen's a really great rocket fuel because it's highly flammable. That means it burns really easily. And when it mixes with the oxygen in the tube, it should cause a big explosion. Let's take a look. Wow, that was incredible. Did you see what happened? Our explosion caused our rocket to fly high up into the air. But what was actually happening? Now, we know from Newton's 3rd law that for every downward push, there is an equal and opposite upwards push. And that was exactly what was happening with our rocket. The explosion caused a downward force, which then pushed our rocket in an upwards direction towards the sky. Well, towards our ceiling. But in order to understand what has happened to our rocket now that it's crashed back down to Earth, we need to visit Newton's 1st law of motion. And Newton's 1st law of motion states that the speed and direction of an object will remain the same forever unless a force acts upon it. Now, our rocket here didn't keep travelling up and up and up and up. It eventually crashed back down to the ground. And that's because there was a force acting upon it. And that force was gravity. Now, gravity acts upon us all the time. I'm standing here in the Science Museum show space, and I'm being pulled down to the Earth's centre by gravity. And that's what keeps my feet firmly on the ground. And it's the exact same thing that happened to our rocket. It was launched, and then gravity pulled it back. In real space travel, rockets are launched with the correct speed that's just enough to get them out of the Earth's atmosphere, but not too much that they go flying off forever and ever. Instead, they are pulled by the Earth's gravitational pull into an orbit around the Earth. Now, it's all down to Newton and his laws of motion that we understand how things move. And it's the reason why we're able to send astronauts like Helen Sharman or Tim Peake up to space. Thanks, Newton.
That was definitely uplifting.
Absolutely. So to recap, in a rocket, the engines are reacting gases to generate heat energy. And it's this heat energy that causes the gases to expand. And these expanding gases are ejected out of the back end of the rocket. And the rocket engines push downwards on these gases. And in turn, the gases push upwards against the rocket engine, propelling it skyward.
We have liftoff, although the last time I was around something ejecting gas out of its bottom, well, I've got to tell you, there was all kinds of trouble.
I can imagine. I'm not quite sure I want the details of that. Thank you.
I don't think you do. Thanks so much, Dr. Tim. What an awesome science sesh that was. And there's loads more sizzling science for you to watch, read and test yourself on over on the BBC Bitesize website. Hey, who put this up and where do I apply? Now, many of us dream of being an astronaut, and one person whose dream came true was Major Tim Peake. And today, he's our awesome scientist of the day. Believe it or not, Tim actually saw a job advert to become an astronaut online and had to undertake a year-long selection process where his body was pushed to the absolute limit. He had to experience high G-forces, fly in microgravity, hyperbolic aeroplanes, and even train underwater. After he got through all of that, he was finally selected, but then had to train for a further 6 years before he could go to space. It was all worthwhile because in 2015, he became the first British European Space Agency astronaut to visit the International Space Station, where he completed a 186-day mission. So, what skills do you need to have to become an astronaut in the first place? Here's the man himself, Major Tim Peake, to tell us more.
If you want to become an astronaut, the first thing you should do is carry on what you're probably doing already, which is being passionate about space and following space flight and enjoying what's going on at the moment, but also to find out what it is that you're really good at and what you like doing, because astronauts come from all sorts of different backgrounds and it really doesn't matter. You can be an engineer, school teacher, pilot, medical doctor. The most common thing that astronauts have is that they've been very good at what they've done, they've been passionate about it, and that has been really the launch pad which has enabled them to go on and be astronauts.
Major Tim Peake spent 186 days in space, and it's hoped one day astronauts will be able to explore much further into the universe and even visit neighbouring planets. But what makes up our solar system? Well, who better to tell us than someone who's probably visited every corner of it twice? Who indeed? It's the Doctor.
Hi, I'm Jodie Whittaker and I play the Doctor in Doctor Who. Here's a bite-sized lesson on our solar system. The solar system is believed to have been formed by the collapse of a giant cloud of gas and rock. It's held together by the gravitational pull of a massive star, and I think you may know it. It's the Sun. Earth isn't the only planet in the solar system. 8 planets orbit the Sun. The closest are the 4 rocky planets: Mercury, Venus, Earth, where we live, and Mars. They're made of really hard rocks and metals. They also have a solid surface and a core which is mainly made of iron. The remaining gas planets, Jupiter, Saturn, Uranus, and Neptune, inhabit deeper space. Very hard to get to unless you have the right spacecraft, and I know one in particular that might work. They're huge balls of hydrogen and helium. And a top tip, you couldn't stand on the surface of the planet because it's not solid. And it's not just the planets that make up our incredible solar system. It's jam-packed of other cosmic bodies, dwarf planets and moons and asteroids. All of this makes up the amazing fraction of the universe we call home.
That's it for today. If you need to fill in the black holes of your knowledge, you can always head on over to the BBC Bitesize website for more learning, videos and fun activities. But before I take off again, here's some advice about how to deal with difficulty from down-to-earth and yet out-of-this-world celebrity, Stacey Dooley.
You know, when you're going through a hard time, it can feel so enormous and all-consuming. But actually, you've just got to remember that things change. You know, it's never always going to be like that. You know, it can be very tricky. It can feel very frightening and daunting at times when you're growing up, particularly if you've got something that's perhaps a bit different to everyone else. I suppose for me, my hair was bright red when I was tiny, and there was no other ginger girl in the class, and so obviously people would sort of, you know, say things that weren't particularly nice. Looking back, I wish I knew how lovely it is to be a bit different. You know, you want to celebrate what makes you you. And yeah, the older you get, the more comfy you become in your own skin, I think. I would say if you feel uncomfortable or you're being bullied or someone's making you feel a certain way, you need to talk to someone. People say nasty things all of the time, and now we're all online, it's much easier for them to do that. What I would say is A, none of it matters, but B, it says more about them than it does about you. You cannot soak that up. If I worried about everything that everyone said, I would never leave the house. You need to be proud of yourself, you need to be able to love yourself like the person that you are. Everything else is secondary, none of it matters.
Hello! I said hello! Oh, hang on. Oh. Yeah, that's better. It's me, Benka G, and this is Bitesize Daily. Not only that, but it's our very own Science Week, and today is going to be out of this world. If you're between 12 and 13 and you've got space in your brain for knowledge, we've got truly stellar teachers and cosmic celebrity scientists to help fill it. Wow, great atmosphere. Hang on, I thought there was no atmosphere in space. Coming up, we discover what it's like to live in space. Our awesome scientist of the day is real-life astronaut Major Tim Peake. There's another shiny instalment of The Sky at Night, the Book of the Moon, written and read for us by Dr. Maggie Adarin-Pocock. And beaming direct from the Science Museum in London, we've an experiment that is out of this world.
Hey, Ben. Yep, we're getting ready to demonstrate orbits using our very own giant orrery. Join us later at the Science Museum. Bye.
Science Week continues on Bitesize Daily, and today we're looking at space. I'm not talking social distancing, oh no, but this. 400 kilometers above the Earth is the International Space Station, or ISS. It's a giant research lab that's been orbiting our planet for over 20 years, and it's home to some very lucky astronauts. Before we find out some of the challenges that astronauts on board face, here's more on what the ISS actually is.
The International Space Station. The ISS is 400 kilometers above the Earth. It measures 108 meters long, which is about the same length as a football pitch. It's a working laboratory where international astronauts conduct a variety of scientific experiments and research. The ISS orbits the Earth at a speed of around 28,000 kilometers per hour. That's almost 8 kilometers per second, over 30 times faster than a passenger jet. It only takes 90 minutes to orbit the Earth, so the astronauts see the sun rise and set every 45 minutes. To maintain the station, astronauts do extravehicular activity, or spacewalks, to check and repair the exterior equipment.
It's amazing to think that there are astronauts on board the International Space Station right now going over our heads. And the experiments that are undertaken on the ISS cannot be performed on Earth, and they're only possible because of the high-tech equipment that's used and the special clothing that astronauts have to wear. To tell us more, we're joined by a very special guest from the Science and Industry Museum in Manchester. It's our explainer, it's Hannah Rose.
Hi Ben, it's great to be here again.
Glad to have you in the orbit of Bitesize Daily. I'll just be a satellite over here, but what have you got for us today?
We're going to find out what happens if you're an astronaut and you need a wee. Now, I've got some water and 3 cups. So I'm going to pour the water into one of the cups, like so. OK.
Yep.
And then I'm going to move them around. And what I'd like you to do, Ben, is to keep an eye on which cup has got the water in it.
Sure, I can do that.
Okie dokie. Let's give it a go.
OK, it's like a magic trick on the moon. Oh.
OK. Which one do you reckon has got the water in?
I'm fairly sure it's this one that's closest to me.
OK, you're absolutely sure?
I'm going to say yes.
OK, well, I'm pretty sure you're right, but just to make sure, I'm going to tip the other ones upside down and see what happens. And because I'm feeling brave, I'm going to pour them over my head.
Very brave.
This.
Yep.
OK?
I think I'm right. There's the first one.
Nothing in that one. Excellent.
Yeah.
Nothing in this one in the middle, yeah?
Yeah, I'm sure.
Let's give it a go.
OK. Good. Phew.
Excellent. What about this one at the end? Definitely got water in, yeah?
That's definitely got water in.
Absolutely sure?
Yeah.
Yeah, so it'd be really daft if I tipped this one over my head as well, wouldn't it? In the name of science.
Yeah, I think we'd all quite like to see it, though.
Let's give it a go.
Okay.
In 3, 2, 1.
No way!
What's going on?
No way, that is absolutely incredible.
Well, I kind of cheated a little bit. Before we started, I put something inside this cup called hydrogel. It's a kind of super absorbent polymer that looks like this.
OK.
And look how little we have to use to absorb all of that water.
Oh.
There we go. When it absorbs the water, it turns into a solid, keeping my head nice and dry. We could also use hydrogel to keep astronauts dry.
That is absolutely amazing. Is it the same stuff you put inside disposable nappies?
Exactly. And it's used to make nappies for astronauts to wear inside of their spacesuits, except they like to call them maximum absorbency garments.
Of course they do. Sounds way cooler than nappies.
And that's how you can go for a wee in space. If you happen to have a disposable nappy at home, why not open it up and take a look inside?
Yeah, but make sure it's not been used before, OK? And check with an adult you can do it. You wouldn't want to be using your baby brother or sister's last nappy. That would not be good.
Exactly. And remember, if you've ever worn a nappy, you're basically an astronaut.
Thank you so much, Hannah. That experiment was anything but dry. And be prepared to be amazed again, because later in the show, we're bringing you another unmissable science demonstration. There's a whole galaxy's worth of captivating science content, including videos, guides and quizzes over on the BBC Bitesize website. Rock it straight there after the show. Team, synchronise your watches, because it's now time for the big read. And since it's Science Week on BSD, we've got the next instalment of Dr. Maggie Adair-Pocock's book, The Sky at Night, Book of the Moon. Ideal for you space cadets. Dr. Maggie is totally enchanted by the moon. Her early experiences of stargazing from Hampstead Heath in London developed into a lifelong passion and fascination for astronomy, and in particular, studying the moon. In today's extract, Dr. Maggie shares her experiences of witnessing a total solar eclipse firsthand and how it left a lasting impression on her.
I was able to see a total eclipse myself in 1999, when I travelled out to Le Havre in France, which is in the area where the total solar eclipse was viewable. It was one of the most memorable events of my life. I was very lucky because it was a cloudy day, but the skies cleared about 10 minutes before the eclipse was due to start, so I could see it clearly with my solar eclipse glasses. It began when the light started to dim to something like twilight. Birds started to prepare to roost as the ambient light got dimmer and dimmer. And finally, there was the moment of totality, when the moon passes precisely between the Earth and the sun. At this moment, you get a brilliant halo of sunshine visible around the dark moon, and the sun's outer layer, called the corona, can be clearly seen. It's possible to see prominences, spikes of solar material flowing off the sun's surface. Totality lasted just a few minutes, and as the moon appeared to move on, I saw the brilliant diamond ring effect when the first rays of sunlight shone past the moon, before the usual daytime brightness returned. It was a truly awe-inspiring moment, and I remember having to sit down for a few minutes afterwards to recover my senses, as they were so blown away by the proceedings. Having enjoyed the first one so much, I then travelled to the US to see the Great Eclipse of America in 2017. It occurred in August during the school holidays, so we went as a family. I can still remember the awe on my daughter's face, lit by the sun's corona. Truly magical. On a more practical note, it's important to be aware that any observation of the sun, aided or unaided, should always be performed with suitable eye protection. Directly looking at the sun can seriously damage your eyes. Now, there's something else to bear in mind, and that's that the moon is moving slowly away from us, so the beauty that is a total eclipse will be lost to future generations. Instead, we'll see an annular eclipse, which is one of the 4 types of solar eclipse that we can observe today.
Thanks, Dr. Maggie. And here with me to discuss the book is someone who loves the lunar landscape and has rubbed shoulders with astronauts. It's another genius with a PhD. It's Dr. Tim Gregory.
Thanks for having me, Ben. You know, reading and writing, they're key skills for any scientist. I do it all the time, so I'm really glad to be here today discussing this book.
Well, I'm sure you'll agree. There's nothing crater than the moon. Nothing crater, no, because crater sounds like crater.
Very good. Not sure I can quite eclipse that joke, Ben.
Nice.
Yeah, thank you. Anyway, the book. So I love how Dr. Maggie weaves scientific explanations together with her own personal experiences in her writing.
And how does she do that?
A really nice example is when she tells the reader about her 1999 eclipse experience. She describes it as one of the most memorable events of her life. And she explains that she was very lucky that the clouds had parted just in time so she could see it. So we understand from this writing that your best chances of seeing an eclipse is when the sky is clear and not cloudy. And at the same time, she shares how she felt about it too.
OK, and where else does she do this?
She describes the moment of the eclipse as when the moon passes precisely between the Earth and the sun. And so we learn as the reader that this is what a total solar eclipse is. Dr. Maggie then shares her emotional reaction to this celestial event. She says it was truly awe-inspiring and that she needed to sit down for a few minutes afterwards to recover, as my senses were so blown away by the proceedings.
Incredible. And she mentions her family too, doesn't she?
She does. This gives it a really nice personal touch. She talks about the family trip to the US to see another solar eclipse. And I think as the reader, we really get a sense of how close this is to her. She says that sharing the moment, that celestial alignment with her daughter, was truly magical.
Sounds absolutely awesome, and I guess it's not something that you would see every day, of course.
Absolutely not, and in fact, Dr. Maggie advises the reader to cherish these special moments when they do occur.
Yeah, I agree, and her enthusiasm is truly inspiring. We'll be hearing from The Sky at Night, The Book of the Moon, again tomorrow, and if you want to discover more about this book or any of the others that we've covered in The Big Read, then head online and search Bite-Sized Daily Lessons. Dr. Tim is still in our orbit because we're talking science. Now, earlier, Dr. Tim, we found out about the International Space Station and what it's like living in space while orbiting the Earth. But I have a question for you. Why doesn't the ISS just fall to the ground or float off into space?
Yeah, that's a fantastic question, and it's all to do with the word that you just said, orbiting. So this refers to the circular or elliptical path of a smaller object around a larger one in space.
No. No time for snacks, Dr. Tim. You've got to wait until later.
No, I'm actually going to use these to show you exactly how orbits work.
OK.
All right, now imagine this orange is the Earth, and this grape is the International Space Station, or the ISS for short. Now, the Earth's gravity pulls everything towards its surface, including the ISS. But because the ISS is travelling so fast around the planet, it's travelling at an incredible 17,000 miles an hour, the combination of its fall downwards and its rotation sideways add up and match the curvature of the Earth perfectly. And this perfect speed means that it won't move out into space or spiral down into the Earth.
Wow, that's amazing. And that's why it keeps on going round and round and round, right?
Yes, exactly. And it's not just the International Space Station that orbits the Earth. There are thousands of other satellites and, of course, the Moon. And on top of that, the Earth itself and the other 7 planets orbit around the Sun.
Hey, we're in luck, because not to eclipse your fruit-based demonstration, we've also got the shining brilliance of Alexandra from the Science Museum in London to tell us more.
Today, I'm going to show you our orrery. Our orrery is a simplified version of our solar system. Now, in reality, our solar system is far larger and more complex and doesn't just contain one planet, one moon, and one star. It has billions of other things. But for now, let's just start with our star in the center. Let's go take a look. We know this as the sun, and everything else in our solar system moves around it. Now, this is called being in orbit. One full orbit for us around the sun is 1 year, or 365 days. And this is from your birthday all the way to your next birthday. Now, the length of a year is different for other planets in our solar system. The Earth is constantly spinning, which means different parts of it are in and out of the sun at different times. That's what gives us night and day. The Earth takes 24 hours to spin, so we get 1 day and 1 night every 24 hours. So that's from breakfast time one day to breakfast time the next, for the Earth to completely spin around. But if you have a look at the North Pole here, do you notice anything odd about the position of the Earth as it spins? Yeah, the Earth is spinning at an angle. At the moment, the tilt is pointing away from the sun, and this section, the northern hemisphere, spends less time in sunlight over the course of each spin in our orbit, which gives it shorter, colder days. Now, we know this as the winter season. If we fast forward our orbit by about 6 months, the northern hemisphere is now tilting towards the sun. This means it will spend more time in sunlight over the course of each spin, which gives us longer, warmer days, which means it must be summer. Now, what we've worked out here is that the seasons aren't caused by the Earth getting closer or further away from the sun, but because the Earth is at a tilt as it orbits. The sun is the brightest object in the sky, but the second brightest object is our moon. The moon doesn't produce its own light, it just reflects light like a mirror. And it takes roughly 28 days for the moon to orbit the Earth. Like the Earth, the moon does spin on its axis, however, it takes the same amount of time to spin as it does to orbit the Earth. This means when we look at the moon from down here on Earth, we only ever see the same side of the moon. Sometimes, the moon's orbit passes directly between the sun and the Earth, and when it does, the moon blocks out the light from the sun and creates a shadow over us. This is called an eclipse. So we've talked a lot about the sun, the moon, and the Earth, but our sun isn't the only star in our galaxy, which we call the Milky Way. In fact, there are billions of other stars, so that's definitely something to think about next time you look up at the night sky.
Wow, thanks so much, Alexandra. It makes you realise just how small our planet really is, doesn't it, Dr. Tim?
It really, really does. And it goes to show how much of an influence our orbit around the sun has on our lives. It really makes you stop and remember the fact that we actually live on a planet that's in space. It's easy to forget.
Too right. I mean, without it, I'd never get the opportunity to get my legs out in the summer, eh?
That's a sight none of us want to see, thank you. Anyway, understanding orbits is really important to our everyday lives. As we discussed earlier, it's allowed us to have the International Space Station circling our planet continuously for almost 20 years now, allowing scientists and astronauts to carry out important research on living in space. And it's not just that. Just think of all those satellites up there, because without them, you wouldn't have loads of things. You wouldn't be able to watch TV or use a sat-nav on your phone.
I know, I'd really be lost without both.
Very, very good.
Hey, now you like my jokes. Thanks so much, Dr. Tim. And remember, there's loads more science to get your head around. Just head to the BBC Bitesize website. It's time for another Tim. We've been looking at living in space, and someone who has done just that is our awesome scientist of the day, astronaut Major Tim Peake. He became the first British European Space Agency astronaut to visit the International Space Station, where he completed a 186-day mission, something that was only possible because it recreates the conditions of Earth on board. The ISS provides the astronauts with air to breathe, water to drink, and a stable, pressurised environment to live in. As Tim will describe, living in space isn't a walk in the park. It isn't even a spacewalk in the park.
The International Space Station is like a life support machine that protects us from a very hostile environment. Firstly, in space, there's a vacuum. So we need to live in a pressurized atmosphere, just like here on planet Earth. So the whole space station is a pressurized container. And in there, we maintain the temperature and the humidity and the pressure, just like it is here on planet Earth. We have a few things to help us do that. We're constantly producing oxygen because, of course, the 6 astronauts on board are breathing oxygen and using it up. Space is a very harsh environment in terms of temperature as well, thermal radiation. When you're in the sun, it can be as hot as 150 degrees C, and it can get as cold as minus 150, minus 200 degrees in the shade, in the shadow of the Earth. So the space station has a number of ways of maintaining a steady temperature. We can use materials outside the space station which actually help to shield the sun's rays. We also have electrical heaters which can keep the shell warm when we're in the Earth's shadow, and that maintains a steady temperature on board the space station.
Inside the space station, astronauts live in microgravity, which means they experience weightlessness, something that also comes with many challenges. One of those is keeping healthy. In space, weights that you would normally use at the gym just float around, so it's really hard for astronauts like Tim to keep their bodies in good condition. To stop them from losing muscle, which can make their skeletons weak, astronauts use specially adapted gym equipment. Here's Tim on how to stay in peak condition when living in space. Sorry, Tim, couldn't resist.
When we're living and working in microgravity, we're floating, and therefore the human body is really not working very hard at all. Our muscles are not having to hold the weight of our body, walking around all day, even sitting, we're getting none of that stimulus that triggers the muscles and the bones to keep working. We're having a very easy time. And therefore, if we didn't do anything, our muscles and our bones would degrade. In terms of maintaining our muscle mass and our bone density, we have a multi-gym effectively, and that uses 2 big vacuum cylinders which replicate the force of gravity. So we work out on this machine and it feels as if we're lifting weights.
Wow, to have actually lived in space. Mind-blowing. And if you want to find out more insight from Tim, head to the BBC Bitesize website. You'll also find loads of other engaging videos and fun activities to try too. See ya. I'm Ben Kajee, and this is Bitesize Daily, and welcome back to Science Week, all you 13 and 14-year-olds. If you need to study but are not sure where to start, let us help you plan it. You know, plan it, because it's all about space. Yeah, well, I'm okay with the silence because in space, no one can hear you laugh. What's that scream? Anyway, don't go anywhere because we've got techie teachers, sensational scientists, and a whole galaxy of great information. Coming up, blue sky thinking with flight and how planes stay in the air. Our awesome scientist of the day is totally terrific. It's astronaut Major Tim Peake. The big read continues with Seize the Moment by another brilliant British astronaut, Helen Sharman. And we'll be hurtling over to the Science Museum in London for another inspirational experiment.
Yes, we're here at the Science Museum where we're going to show you how the Bernoulli effect explains how planes take off and fly.
Science Week is flying by on Bitesize Daily. So far, it's been plain sailing, although, if I'm honest, I've been winging it. So the only way is up. And today it certainly is, because we're looking at flight. Have you ever wondered how birds or aeroplanes soar through the air? We've got the perfect experiment to show you. And while we prepare for takeoff, here's the lowdown on the science around flight.
Flight, wing structure. Birds and aeroplanes rely on 4 forces to fly: thrust, drag, weight, and lift. All 4 forces are acting on an aeroplane whilst it is in flight, but lift is what keeps it up there, and this is because of the wings. The shape of a wing is called an aerofoil, with a long curved edge on top and a shorter, flatter edge underneath. When the wing moves forward, this shape makes airflow faster over the top of the wing, creating lower air pressure than below it. The difference in air pressure pushes the plane upwards, creating lift. A bird's wing is the same shape as an aeroplane's, creating lift in the same way so they can glide through the air.
To explain more about flight, gliding in from the Science and Industry Museum in Manchester, welcome to Bitesize Daily. It's super science explainer, it's Maxwell.
Hi, Ben. Great to be here.
Now, what have you got for us today?
Today, we are going to be demonstrating how aeroplanes stay in the air. Similar forces work on aeroplanes in the sky as on paper aeroplanes you can make at home.
Awesome. I love paper planes. OK, let's see what you can do.
Here is an A4 sheet of paper. To start, fold it in half.
OK.
Now, bring in the 2 top corners to make a point.
Yeah.
Now, bring in the diagonal edges so they meet in the middle.
Hey, you've done this before.
Lots of practice. Now, fold your paper plane in half.
Yep.
And bring down the diagonal edge so that it meets the straight edge to make your wings.
OK.
Go.
Nice.
Now we have a plane. Let's throw it and see how far it goes.
OK. Whoa, yeah, nice, great skills. Now, talking science, though, why doesn't gravity pull the aeroplane straight down to the floor?
Well, when you throw your plane, you give it thrust. As the plane moves through the air, the wings generate lift. The air moving over the top of the wings moves faster than the air moving under them, helping to keep the paper plane in the air. Eventually, though, air resistance will slow your plane down enough for it to fall to the ground.
Hey, it did make it quite some way, though, on its maiden flight. Do real aeroplanes behave in a similar way?
They do, but obviously they have powerful engines that keep pushing them through the air. The engines give them the thrust they need to stay up.
How could you change your design to keep the aeroplane in the air for longer?
You could experiment with adding different weights, or maybe try taking inspiration from planes you have seen, or even come up with your own brand new design.
Nice, I like that idea. Before you embark on your own flights of fancy, there's loads more amazing science content, including videos, guides and quizzes, over on the BBC Bitesize website, just like this. Just imagine being the first person from your country to go to space. Well, British astronaut Helen Sharman did just that in 1991. And this week, we've been hearing extracts from her inspiring autobiography, Seize the Moment. In this extract, Helen recalls how she and her team, Russian cosmonauts Sergei and Tolya, have taken off from Earth on a rocket and are heading for the Mir space station. Since the initial stress of takeoff has eased, Helen has had time to reflect on her role. And in today's extract, Helen describes some of the scientific experiments she conducted on her historic mission.
We took up a tiny lemon tree, so small as almost to be a bonsai. The idea of this was to see if higher plants can actually be kept alive in space. This will be important in the future if we want to be self-sufficient in space, such as during a long journey to Mars or one of the other planets. We know we can grow seeds, but producing fruit or flowers inside a spacecraft is still a largely unknown quantity. An experiment called Vita was one in which it was possible to mix the contents of different cells with different media, trying to dissolve the cell walls, mix the contents, then grow the cells and make them replicate. I took up 125,000 seeds for later distribution to British school children. All I had to do was look after two separate samples, one which went with me into space and the other which went everywhere but into space. These seeds were later sorted out so that each school received some seeds from each sample. The children could then monitor the growth, noting what differences, if any, might appear. Finally, there were two onboard experiments I found particularly interesting. The first was growing luciferase protein crystals. On Earth, you can't grow these crystals big enough because convection currents arise in the solution as the crystals form. Using a number of different concentrations, temperatures, times and pressures, I was able to grow the same crystal, determining which conditions were best for its growth. When I brought them back, the crystals were big enough to be analysed by X-ray crystallography, so it would have been possible to determine the structure of the protein. From this, the design of medicines can be based. These crystals can't be produced large enough on Earth. I hope you enjoyed that. Do join me again tomorrow for another extract from Seize the Moment.
Thanks so much to Helen there, a fascinating first-hand account. And joining me here to talk about the book is someone who has had an insight to astronaut training himself. It's the very well-read Dr. Tim Gregory.
Thanks for having me then. I'm really pleased to be here on Science Week, and of course, writing is so important in all of the sciences, from experiments to research and expanding our knowledge of the world around us, the universe and beyond.
Yeah, it certainly is. You mentioned experiments there. Why did Helen take seeds and plants with her into space?
Good question. So the aim of this experiment was to build on the current scientific understanding that seeds can grow inside a spacecraft, and to see if it was possible to also grow fruit and flowers in space.
OK, but there must be so many experiments that scientists want to try out in space, so why did they choose that particular one?
So the main purpose of doing this particular experiment was to see if, in the future, astronauts could grow their own food on their own spacecrafts, making them self-sufficient as they travel around the solar system.
Hey, it sounds better than those silver pouches of food they eat in space. You know, that stuff, that reminds me of cat food.
Yeah, absolutely, and it might be a bit tastier if you grow your own food. But most importantly, travelling into deep space takes many, many years. And to do this, astronauts will need to be able to grow their own food along the way.
I see. So what about the seeds? There were loads of them, right?
Absolutely. There were 125,000 seeds, and all these seeds were split into 2 samples. And Helen took one of these samples into space and kept the other set back down here on Earth as a control. And the idea was that when she returned, both sets of seeds would be given out to school pupils across the country so that they could grow them and compare the 2.
OK, to see if the seeds that had been in space still grow the same or differently.
That's exactly right. And it was also a great way to inspire pupils, you know, the next generation of scientists and astronauts.
Brilliant. So Helen's mission was not just to go into space, but also to sow a seed of interest in science for school kids too. Amazing. And we'll hear from Helen again tomorrow. But if you want to find out more about this book, then head to Bitesize Daily Lessons. Not you, though, Dr. Tim. You're needed for a further mission.
Fantastic.
So, Dr. Tim, what are we looking at next?
Right, so earlier we learnt how aeroplanes were able to fly up and stay up in the air. And right now, engineers and scientists are working on a plane that will be able to fly so high into the atmosphere that it'll be able to launch a rocket directly into space.
Wow, that is incredible.
It really is. And it's only possible because those scientists and engineers understand the theories behind flight. Now, as you've seen already, that one of the reasons why planes stay in the air is because of lift. This is the upward force that the air exerts on the wings of an aeroplane.
Yeah, the paper plane certainly flew across the studio earlier.
It absolutely did. Now, the reason why aeroplane wings generate lift can be visualised by a theory called the Bernoulli principle.
Well, Dr. Tim, before you go any further, we're in for a treat because Sam and Alexandra at the Science Museum in London are going to demonstrate the Bernoulli principle in action, especially for us.
And today we're looking at fluid dynamics and the Bernoulli principle. Now, an important thing to know is that fluids doesn't always mean liquids. It's anything that flows around an object. So gases can also be fluids. Now, this is all very important when designing wings for planes. When the plane is travelling at great speed through the air, the wings are designed to split the airflow with the air moving faster over the top of the wing and air moving slower underneath. The Bernoulli principle tells us that fast-moving fluids have a lower pressure than slow-moving fluids, which have a higher pressure. So on our plane, we have lower pressure on top of the wing and higher pressure on the bottom of the wing. And high pressure always wants to move into low pressure. So all that high pressure underneath is trying to go up to be low pressure, and that generates lift for our plane. But what about if we have a different sort of shape? Maybe a sphere? Well, I'm going to throw this into the column of air from Alexandra's leaf blower. When I throw the beach ball into the column of fast-moving air, it will push it up into the sky. Have a think about where the fastest air is going and what that means for the differences in pressure. The fast-moving air is flowing around the ball because of its shape. Remembering that high pressure moves to being low pressure, it means that the slow-moving air in the atmosphere is moving towards the fast-moving air around the ball. As this is happening around the entire sphere, it keeps the forces balanced, and our ball ends up hovering. You can do this at home with a hairdryer and a table tennis ball, or even more deliciously, with a light chocolate ball and your own breath.
Hey, I told you it would be dynamic, Dr. Tim.
Could say it was aerodynamic.
Nice, I like that.
Fantastic. So, it explored the relationship between airspeed and pressure. And the way the wings of a plane are shaped actually controls the speed and the pressure of the air flowing around them. You can change the shape of a wing to reduce air resistance, also known as drag, which would make it more streamlined and aerodynamic. You do, of course, have to make sure it's still big enough to provide the lift, not forgetting that the thrust of the engines and the weight of the plane itself also play a part. So there are 4 forces of flight. The first one is lift, upwards. We've got thrust, forwards. We've got drag, backwards, and the weight of the plane caused by gravity, downwards. And maintaining a steady flight needs all of these forces to be perfectly balanced.
Hey, that explanation was anything but a drag, and you had great gravitas, Dr. Tim. Don't forget, there's more sparky science experiments, videos and quizzes over on the Bitesize website. We might have seen rockets launching into space, but have you ever wondered what happens when a spacecraft comes back down to Earth? Someone who is very familiar with this is our awesome scientist of the day, Major Tim Peake. Astronaut Tim Peake spent 6 months on the International Space Station, and after his mission came to an end, he travelled back to Earth on the Soyuz spacecraft. It wasn't a straightforward journey, however, because he had to re-enter the Earth's atmosphere, a difficult task that can be fraught with danger before landing in a desert in Kazakhstan. Here's Tim to describe the challenges he faced and how he prepared for his epic journey home.
One of the things that can happen to the Soyuz spacecraft when it descends is that it will fall at a steeper angle, and that's called a ballistic re-entry. Very serious situation.
При баллистическом спуске никакого управления нет. Корабль закручивается вокруг своей оси, потому что вот эта закрутка и перегрузка больше в 2 раза, она может быть и в 3 раза больше.
The reason why I did the centrifuge run today was to get me used to the kind of G's that I'm going to be exposed to. 8 Gs is exposing you to the re-entry, and that's only really if the re-entry goes wrong. You might get up to 8 to 9 Gs for 30 to 40 seconds.
Just try to breathe.
It's like having an elephant sitting on your chest, so you can't possibly breathe through your chest. You have to breathe through your abdomen and almost gulping for air just to try and take short breaths and just to keep that oxygen flow going.
That video was universal, but if I was experiencing a ballistic re-entry, I think I'd want parental guidance. Scary stuff. We've had a packed lesson today, and now Dr. Tim is back to put me through my paces with one of his legendary quizzes.
All right, first question. What is the name of the upward force that moving air exerts on the wings of an aeroplane?
I think I know this one. I think it's lift.
Yes, perfect. Yes. And it's this lift that helps keep the plane in the sky. All right, question 2, Ben.
Uh-huh.
What is the name of the theory that can visualise lift?
It's a good one, and it's got a great name, the Bernoulli principle. It was such a cool experiment to explain it as well. I liked it.
Fantastic, correct. All right, final question. When an astronaut returns to the Earth, what name do we give it when the atmospheric re-entry is steeper than normal?
Right, this sounded absolutely terrifying. It's a ballistic re-entry.
Fantastic, 3 out of 3.
Yes, get in. Thank you so much, Dr. Tim. What a lesson. That's all we've got time for, and if your head isn't spinning like an 8G gyroscope, you can check out more on the BBC Bitesize website. There are loads of videos and fun activities. Plus, we've always got your back, so let us know how you're getting on by using the hashtag BBC Bitesize Daily. Before we go, here's some really top advice from Radio 1's Chris Stark. Now, if you'll excuse me, I'm off to dream about being in space.
You can't avoid the pressure that you feel to look a certain way. You can't, because it's everywhere. You see it online, you see it in magazines, you've got your mates all progressing at different stages of their life. Some of them have boyfriends or girlfriends. Everyone is different, but in a weird kind of way, everyone's just trying to be the same to get by and keep pace with everyone else. I stopped wearing football shirts to school discos and suddenly decided that I needed to wear a shirt and do something with my hair, and I discovered deodorant. I'll be honest with you, that's what I thought would get me a girlfriend. And I was wearing the same shirt that every other guy that I knew was wearing. Nothing made me really stand out. As I got slightly older, I've realised that that little bit that makes you stand out is the bit that someone is looking for. If everyone looked the same, this whole game wouldn't work.
A new dawn awaits.
The battle of light versus dark has begun. We are going into the storm.
I'm still coming for my rubies.
Who will reach the knot first? The world's future is at stake, but there are many tests along the way.
I can't get him off my head.
Who's with me?
You have to choose.
I'm not a real vampire, just a girl.
I have
to keep her on her path.
And danger is never far.
All that power.
She'll come back to save us.
Shining trap.
Brand new Heirs of the Night. Streaming now on BBC iPlayer.